Yeah, hello. This is Amritansh, and I'm taking a demo on deep learning that will be powered by Learnbay. And so, just to give you an intro, this is a course about deep learning, which is essentially neural networks. And my name is Amritansh. I did my MS in CS from University of New Mexico, Albuquerque, USA. My concentration was in artificial intelligence, and I did related courses and projects in artificial intelligence as well as in machine learning. Right now, professionally, I'm a researcher and a consultant to startups and corporates, and I'm a mentor for Advanced AI. That's a research group for RLA meetup in Bangalore. I'm also mentor of change for Atal Innovation Mission, that is AIM, that is run by Niti Aayog. And that is mostly to teach school kids about robotics, coding, artificial intelligence, and machine learning. But yeah, enough about me. Let's see what this course has to offer, what this course is really all about. Let's talk about intelligence first. What is intelligence exactly? It's slightly tough to define, but whatever it is, and we definitely possess it because we have kind of tried to quantify it for so long, and even without quantifying it completely, it has changed our lives. It has been responsible for human race, progress, and source of all creativity, its technological advancements and success in modifying the environment. So for example of agriculture, that earlier we were nomads, and then we understood or like kind of figured out what farming is. Then we started agriculture, we started growing food, and then we started to settle or to building dams to harness the power of water just falling from a great height to produce electricity. Intelligence kind of measures an agent's ability to achieve goals successfully, and that's the important point, in a wide range of environments. And we humans and a lot of other animals such as dog, rats, beavers also build dams. They kind of fit into this definition. Although none better than humans, we can like kind of adapt into large variety of environments. Intelligence is a very general kind of mental capability that, among other things, involves the ability to reason, plan, solve problems, think abstractly, comprehend complex ideas, learn quickly, and learn from experience. This is one of the universal intelligence of agent pi, and that can be defined as a summation of all the environments where it can work, and the rewards could be observed, that is 2 to the power minus k to the power mu, where mu is all kinds of environments you can have, and 2 to the power minus k into mu is just Colmor's complexity that kind of defines the simplest computer code or program which solves the environment into v given pi by mu, which basically means for any environment what is the chance of success. And if you just sum it up, that is a kind of a smart definition for universal intelligence for any agent pi. It could be artificial, it could be natural. Okay, so moving on. What is artificial intelligence? Artificial intelligence is an area of computer science that emphasizes the creation of intelligent machines that work and react like humans. Now, this is very key. This idea is a very important idea, that artificial intelligence, all in all, is a scientific study at the end of the day, and it deals with creating kind of human mind or something similar to human mind, which is where near par in performance and ability to transfer its learnings and be again successful in different areas. As already has been talked about, intelligence has been a key factor in the advancement of our race, and it's about time we amplify human impact along with artificial intelligence. So whatever we are doing, we figure that with a good enough artificial intelligence, we can amplify the impact maybe 10 times, maybe 100 times. And it is true for our day-to-day lives, businesses, and even just for our environment and overall success of our human race for next 100, 200 years. The core problems of artificial intelligence include programming computer for certain traits such as knowledge, and this is very evident that we do want an artificially intelligent system to have knowledge. It should be able to reason, so that's why the second point is reasoning. Then problem solving, this might be the one of the most important part, that it needs to solve problems. That's why we are so interested in developing it, because so that the problems which might take 10 years, 20 years for a group of humans to solve may be solved in few hours, maybe even weeks, and that would be a tremendous advantage to us. Perception, how do we perceive the world? So a computer also perceives the world given through its sensors. But what do you make sense of the perception? That is very important. Then learning. Learning is very important. Otherwise, we will be just working with very symbolic based rule systems that something has been specified and that's how you always do it. But no, your environment keeps on changing. You need to learn and then adapt to survive. And similarly, your data or your problem statement might keep changing time and again. And it becomes imperative that a system learns. And then it also has to plan. Because once you have started to learn, you can see long-term traits or long-term signals. And maybe you will be able to plan well enough or well ahead of time so that to reduce cost and reduce uncertainty. And that's a major gist of the work we do with artificial intelligence or even machine learning, that we need to reduce our overall uncertainty. We need to reduce the overall loss to our businesses or like any organization, and that's what makes it like a very important field to study and kind of be very good at. And similarly, machine learning is just a subfield of artificial intelligence itself. It's not anything different. People have been kind of working in machine learning for last like 70 years already now. It's a field of study where we program computers to learn without being explicitly programmed. Now, this might be slightly confusing us to hear, but we do program these machine learning models by ourselves. The idea is we just give them a general set of instructions and they deal with the changes in data or changes in the problem statement based on some mathematical rules. And we will talk more about in the course about that. It is definitely a core part of AI. Learning without any kind of human supervision requires an ability to identify patterns in a stream of inputs, whereas learning with adequate supervision involves classification and numerical regressions. If someone has done basic data science course or machine learning course, they might already understand what am I saying or trying to tell you guys. But even if you have not covered it, don't worry, I will be happy to help later. It has been one of the most successful paradigms in terms of AI research so far, and that's pretty much true. Most of other fields have not seen this much success as machine learning has. The commercial applications have been endless, and every day we are seeing new commercial applications and use cases. Few examples are recommender systems, anomaly detection, your classifiers made with images or video, generative models, and regression techniques. Moving on. Now, how is all related? First, let's understand, and this is like a lot of people might already understand this, but AI is the study of creation of machines which mimic performance of human given limit on processing and time to achieve the goal. So it could be anything. It could be machine learning, it could be a Bayesian approach, it could be a rule-based system, it could be a reinforcement learning system. Everything falls under artificial intelligence. It's a big umbrella. Machine learning is a subset of AI, depends on experiences through data, and that is what at the core of machine learning is. That while looking at different data points, it kind of starts to learn through these experiences, and that it applies for the predictions. And deep learning itself is a subset of machine learning, doesn't require hand engineering of parameters. We will come on that exact point a bit later. We have a slide for you. But let's understand where the inspiration even comes from. So we do know our processing comes from within our human brain, that is biological. But it is like one of the most complicated structures, and this mystery is how it really works, or what is the grand unifying theory, the way our brain works are very much an active area of research. We do not exactly yet know how this thing works. But we do have some insight about individual brain cells called neurons. and one structure is kind of given to you. You can see it has got dendrites and axons. It has like a cell body which has a nucleus, which is also called soma, and it has a long axon where like signal really propagates. All the encoding is done by dendritic connection throughout the brain, and that is kind of true that on an average we have like 80 kind of billion neurons, but we have like 1,000 to 10,000 connections per neuron. That makes it, that number goes very easily into trillions, like almost 100 trillion. That's the number exactly. The idea is these connections, the way our connections are being formed from childhood to till we kind of die, that determines who we really are. And it has been scientifically proven that if we somehow alter your brain connections, we can even change your personality. Deep learning is a very rough approximation of our brain's mechanism. A lot of people call it is not even the true mechanism. And thus, I will agree with that. It's not the true mechanism, but it is a rough approximation on whatever we already know about the brain in order to learn from experiences. Again, it doesn't give any more insight about the planning and some other problem solving parts. But to learn from experiences, to use it in pattern recognition, it is amazing. A little trip down history lane. Hubble and Wiesel and the neural basis of visual perception in 1950s work. And that was like one of the pioneering work which they kind of showed cat lightning rod and kind of recorded the encoding within its brain. And that showed like we have these unique encodings for each angle. And if it is vertical, there is a different encoding. If it is horizontal, it is a different encoding. And then perceptron paper by Frank Rosenblatt kind of came in 1958, which actually started the work in artificial neural network. At that time, they were actually called multi-layer perceptron, or the actual Rosenblatt paper just gave the idea of perceptron, a single node. 1918 Fukushima paper laid down the foundation of CNN. It was not called CNN at that time, but it did kind of work with the hierarchical feature detection. So at one layer, there is a very sparse representation, and then you kind of keep going down or deeper, and you figure it out there is much higher richness that can be extracted. Then Hopfield networks were discovered by John Hopfield in '82. They were kind of precursors to RNN, that is recurrent neural network, and eventually LSTM, long short-term memory, which is like regularly used in your speech processing or even NLP, that is natural language processing. Parallel distributing processing revolution was started by David Rumelhart, James McClelland, and Geoffrey Hinton back in '84, and that is kind of the thing which we are doing with CUDAs and other parallel processing. Backpropagation, the backbone of error correction in DL, was used for first time in ANN by 1986 by Geoffrey Hinton Research Group in University of Toronto, and kind of modern day CNN, which we call LaneIt1 now, came out in 1989 by Jan LeCun at Bell's Lab. So let's see what artificial neural network exactly is. So this one just kind of represents kind of one node at the end of the day, that you have like multiple weights and you have a layer, but it kind of comes down. So the representation is not complete, but we will see that in the very next slide itself. You can see that we have an array of inputs, that is x1, x2 to xn. Similarly, we have all these weights just for one layer, let's say. That is w1j, w2j to wnj. And there is a transfer function, which is basically a summation function here, which kind of gives us the net output, that is net j. And you can understand that using net j is equal to a very simple summation of xi dot wij, that is a dot product in vector multiplication. And then we kind of apply an activation function. So I will come on the activation function part a bit later. But again, that is one of the key advancements what we have seen in the artificial neural network world, apart from the backpropagation. And when you apply that, that is phi.netj plus theta j, basically that is just a threshold, you get the output. Okay. And that is the activation which we want to get layer by layer, or as we deem fit, it could be after 3 layers, after 4 layers as well. And this is just the kind of like a complete representation I have tried to provide. Any artificial neural network actually contains multiple layers of artificial neurons. The first layer is called input layer that has been represented by an array of in, and last layer is output layer by on. Anything between these two. All these inner layers are referred as hidden layers. And these are the layers where actual magic happens, or the actual kind of trickery we do is happening. That is pooling, subsampling, activation, dropout, convolution, compression of data. And activation is important because it kind of changes or your transforms your data, the input data. So if it is lying on a 2D plane, it can be let's say lifted to a 3D cube. And then maybe the division or the partition line for the classification will become much simpler for us. We will come on that in the course itself, that how we exactly do this. But just for your reference, you can kind of take this intuition from the kernel trick in SVM, where the kernel is applied and it kind of folds the data into folds, or like kind of raises the data into higher space. And that's where you have these very straight classification hyperplanes. Something of a similar idea is this idea of activations. It kind of induces non-linearity in the whole system or the data, and that sometimes helps to approximate the function much better. Moving on. So what is deep learning exactly? We have been calling it artificial neural network or perceptron. So basically, in a very simplistic word, deep learning is learning done by artificial neural network, which has more than one hidden layer. And that's the ground truth, okay? So anything more than one hidden layer. So you have the input layer, you have the output layer, and you have more than one hidden layer. You can call it a deep learning system. It's very simple, very generic definition, but yeah, it is true. The core intuition is that deeper the network, or that as the deep the network is, deeper representation and present in data could be extracted. And I will just show you 1-2 examples that how exactly it happens. It has been proved that neural networks are universal function approximators. And now this is tricky. The proof is slightly long and we can go through in the class as well, or I can provide this extra information through the course itself. But what it implies is that given enough training data sample and time to converge and deep architecture, so it takes time. It may take time to converge or figure out that exact function, but it will figure it out. It depends how we architect our network, tune our hyperparameters such as learning rate, momentum, choice of activation function, and loss function. But if we do this or keep on doing this, we will approximate that function, or the neural network will kind of approximate that function for us. It actually works very well with noisy or incomplete data as well. But the idea is you have to have pretty much a large data set. So it can kind of get ahead even if some data is noisy or missing, it doesn't matter. It will still approximate the underlying function. And that's what we want. Once we figure out what is the function, we can predict what is going to come next. And that is the key kind of concept behind the whole machine learning, to make these predictions for the future. And these are the very simple ideas that how DL or like machine learning or even let's say ANNs, artificial neural network sees. So let's say we are talking about a face detector. You give multiple faces and you have these massive networks, and these have a lot of let's say like first 2-3 layers. These are like input layers, and whatever like processing happens, you can here see these are straight lines or straight line detectors. Those are the first very sparse representation that you get. Then as go deep you go, you start to get these rich kind of detection, that some part will be detecting a nose, some maybe the left eye, some will be doing the right eye, and left chin, right chin. And then as deeper you go, closer to your output layers, you kind of start to get these images, even in grayscale, which this picture might look very similar to this picture. And that's how it kind of tells with certain probability that yes, this is the face of this person. Similarly, you can again go with another example, and this idea is exactly the same. You have these input layers, and the first it tries to break it down to much straight lines or the very sparse representation. Then it goes for the deeper representation, that is somewhere you might be able to see a wheel, maybe a door, maybe car body, and then it goes much closer to being a complete car. And let's say it kind of produces Audi A7. And this has been directly taken from unsupervised learning of hierarchy representation with convolution deep belief networks. And I would encourage you guys to even read more papers during the course as well. So what's so special about it really? Why we are so happy and this revolution is like something changing our lives? Well, it is extremely good at inference. Okay, given enough training samples. If you have the good data, and it usually requires large amount of data. A trained network is lightning fast with predictions. Once the model is trained, then it is supremely fast. There is like no beating it with any other network or like any other uh, model, machine learning model. It can actually escape curse of dimensionality with certain architectures such as CNNs or autoencoders. So curse of dimensionality is as we increase the feature space, you have to search more features or more feature space. So let's say you are dealing with a one-dimensional feature space. So if you are standing at one, and so kind of consider a single, 1D is a line, okay? So you are at one and you have to search till five. So you only have like four blocks to search. If you know like which direction at least you have to go. Let's say you start at zero. You have to search till five. So you only have to search five blocks. Now make it a 2D thing. So that would be a plane or a square in this thing. And again you are at 0, 0 now, but you have to search till 5, comma 5. Okay, that's a square. Now you have like 25 blocks to go through. Similarly, in a queue, you will be standing at 0, 0, 0, and now you will be having like let's say 125, and that is like if you understand that is just growing exponentially, and that happens with more number of features. Most machine learning model doesn't tends to do that well, so we have to many times cut down on features. But usually with certain special architectures such as CNNs and autoencoders, neural networks can escape the curse of dimensionality. So it doesn't like kind of screws up or like it actually does better with like more features. We have found good accuracy with training data as well as the test data, and they are like constantly achieving superhuman performance with standard data sets in different fields such as CV, NLP, speech, and voice processing. Can be modified to work with large number of problems, and domains are like getting increasing like every day. Image detection, object detection, segmentation, face recognition, NLP, speech recognition, and generation, narration, recommendation. They can be mixed very well with other approaches in AIML, such as like reinforcement learning and deep learning. AlphaGo was one of the prime examples. And with so many frameworks and APIs, it is pretty easy nowadays to implement in real world problem statements. And that's what we are very much interested about, to apply them in real world problems, because this domain was like very much academic 10 years ago. Now it has become so much commercial, like big companies like Google, Microsoft, Facebook, Apple are investing like billions of dollars on AI research, but also they are investing almost billions of dollars to commercialize it. So you might have heard about Google AutoML, which is a pretty much an API based kind of library, and that is trying to help down data scientists in order to kind of solve the regular problems which they occur on a daily basis. Just through help of APIs, you do not need to know the complete coding part even for that. But here we will be dealing with, in this course, we will be dealing with the nuts and bolts of deep learning. So your learning will go much deeper than most data scientists. So before going and like just it's a very basic comparison between like machine learning and deep learning. So one of the major things which you might be able to see, and please ignore the like the picture of classification machine learning. Just think of it as a network. It could be any network. It could be a simple machine learning model. But the simple thing which you see, the feature extraction has to be done by a person, which has been represented by a person sitting in front of a laptop. So it means you have to do it. As a data scientist, you will have to do it. Okay. But deep learning kind of takes that out of your hands. So it becomes pretty automated after a while. And that's what again is like driving a lot of into, because in machine learning, a lot of things has to be done by you. Mostly they are hit and trials. No one exactly knows how even that works. But it is a time consuming process in a very simplistic word. In deep learning, you kind of automate it. Still, it will take time, but it has like automated it. So you do not have to worry. Deep learning will approximate that function for you. And just going into slightly more detail, the biggest advantage in favor of deep learning is no hand engineering of parameters or features. Okay, and that is important. It's kind of automated. Although still there is a maths, how do we do it? It's not exactly like a mystery or anything, but it is a very serious maths. It works with very well actually with large feature space, where as I told you, like it kind of doesn't suffers with curse of dimensionality, where most ML models actually struggle to do any better. So like most models, ML models actually do very well with like 100, 200 features. And after, let's say you increase it to 1000 features, the performance doesn't goes up usually. But deep learning, actually it will go up. It works very well with noisy data as well, but it is like a tricky thing to say because actually you're showing too much of data anyways. So it can practically ignore that noisy data point. Overall, it saves a lot of time for developers or data scientists, and they can kind of focus on solving the problem, and deep learning will figure out the underlying classification of the regression curve which it has to figure. And it has constantly outperformed most ML models with large samples of data in terms of accuracy, loss, and precision. And that's the truth. You can kind of keep on reading papers these days, and every day they are claiming a better accuracy or even a smaller loss percentage. But again, it's a tricky point. It doesn't mean DL is the best solution for every problem. Each problem is unique and exploratory data analysis must be performed beforehand in order to determine best suited technique. And this is very useful advice. That it doesn't mean like every time you see a problem, you just start with deep learning. Deep learning has certain requirements and like it does require higher processing power, no doubt. The best thing is processing power has become cheap. That's the only way. But otherwise, it's still a costly affair in terms of processing and memory. Okay, there's always a trade-off in versus any ML model and DL. If DL gets this better accuracy, it comes with large amount of training data. That's the like kind of the first thing. Let's say we all have like powerful computers nowadays, but still to get these large amount of training data could be very cumbersome in a lot of industries. A lot of industries do not like to share their data. If you are working in the internal or the core team of their data science team, it's very well, then you will have the access. But let's say you are doing some work for your client, but they are not willing to give you like, they are willing to give you maybe some historic data, which might not be even the 5% of the actual data. Deep learning might not be the best solution at the very first. You might be able to build a basic prototype with some other ML model. Once your POC is approved, then you might be able to go with the deep learning and with the good large enough data, because that is like very much required over there. So let me do one thing for you guys. Uh, let me show you some other things like how we can do this. So I think I have something for you. So kind of Google has launched this, uh, it is called like neural network playground. Okay, it is on playground.tensorflow.org. And I kind of like it because it gives us very good of these simulations and like we can like organize it. So they have, or like I can create a basic neural network. Okay, so 2 hidden layers or 3 hidden layers or even 4 hidden layers. And here is your data. So this has just two classes right now. Okay, either it is blue or it is yellow. Okay, the idea is to find dividing line or lines which kind of classify the data very accurately. Okay, so let's just see. So again, if it doesn't make sense, don't worry, everything will be covered within the course, but it is just I'm trying to show how these things work. So ReLU is the rectified linear unit, and this will kind of give you very straight lines. Okay, L1 is the kind of a regression penalty, and you don't have to worry about right now. Okay, we can select, there are different data types. So let's select, try to have some more complicated ones. So this looks very easy. It is a straight line problem, so I will not select that. This looks like slightly tricky. Okay, SVM can solve this very easily with the radial basis function. But let's see what happens really with ReLU. See, now I can pause it because I know you can see here the loss has flattened out. So it doesn't matter, like you do not need to train even more. But you can see these lines are very much straight, right? Because we have taken ReLU. Now let's try this, and you can see that overall loss is really low. Okay, it's not even like 1%. It's like 1/10 of 1% actually. So let's go with Stanage first, okay? And let's see what happens now. And okay, let it run. Now you will see the graph is kind of converging. Yeah, it has converged already, okay? Because again, you can see line has flattened here, so it doesn't matter now. You can see the graph is very smooth. The curve is very smooth because Stanage can have those non-linearities which let's say ReLU would not be able to provide. Let's use sigmoid. Sigmoid is again slightly different. My experience is sigmoid will take more time on an average. So you can see this number here. And you can see the loss is not even changing for a long time. And usually it doesn't changes for a long time. And then all of a sudden it drops. But it depends on your data as well. It might not work every time. But I can see like there is a very general change. So it looks like there is nothing happening. So if nothing happens, we can actually even stop it just to go with some other model. It looks like it has flattened out. It is not going to figure out. And that's the problem with Sigmod. Actually, it will not be able to figure out this plane. Okay. It can do a very simple one. So let me show you a simple one. So let's say we select this one and then apply Sigmoid. That it will be able to solve very fast. So it doesn't seems like, but yes, it is converging. It just takes more time on an average, okay, but it will figure it out. But again, like sigmoid itself is not a very good one to classify. It still kind of brings like a very straight line phenomenon here. And anything which gets more curved will have more problems. So like this one is not going to be easy, okay, for anyone. So I will start with my favorite ReLU anyways. So let it train this time. So you can see here the graph is figuring out, okay, it will figure it out. That's the best part. But it may take like a long time because it is not figuring out how to like really like curve here. And that's a big problem for it, okay? So again, ReLU might not have been the best idea because with this much curve, you might need actually tan edge. This is not going to work anyways. Here we can see it has pretty much flatlined, okay? And it is not going to do any better now. It's very tough for it to actually recover from it. So you can actually see what each node is learning even. So initially you can see they are pretty much straight lines. There are no curves or anything. Then the slight curvature starts actually. Here the curvature has even increased. And you can see the curvature is much more here. So just to check this tough one, let's try with this tan edge. As you can see, it has already started with the curving part. It might not be very visible, but it has already started right now. Let's see, does it does any better or like it does even worse. So it looks like now it is starting to converge. You can see these graphs coming down slowly, very slowly actually. Yeah, now it has started to do something really funny because it is trying to kind of modify itself around these blue lines and these yellow lines. And here you can like go and you can see like what each node is trying to do. Like every node is trying to learn. Again, initial you will see like very straight lines or like completely one plane. And that is just, okay, so this tool is just to give you an intuition. Again, like we can apply some more tough or like more complex techniques to go in this direction and that will like solve this problem. But it is a tough one without any doubt. It is definitely a tough one. It is not an easy thing to kind of just go there and like kind of work it out, okay? So, okay, switching back. Okay. Okay, so we were at machine learning versus deep learning itself. So as I showed you in a very simple example, like how this thing works exactly, and we will kind of keep experimenting with more and more techniques and more layers as well. So what are these application areas? And these are actually very much plenty these days. Computer vision is like one of the most well-known. It is object localization, face detection, object detection. It could be even emotion detection or like pose estimation. NLP could be semantic analysis. Word2vec has been one of the good uses. Word2vec is basically a technique just to convert to vectors, but Word2vec has also become a kind of complete library in Tensor Flow. Speech WaveNet. So WaveNet is kind of been developed by DeepMind, and again it has used neural networks to create a very human-like voice, which is kind of been generated in Google now. Okay, you can do text summarization, gameplay, AlphaGo if you remember, a combination of deep Q learning to play Atari games. Spam detection, detecting of fraud emails, that's how like Gmail and other companies are doing it. Medical data analysis, data compression. Anomaly detection could be in terms of cyberspace or like anywhere where any hacks are happening or like corrupted files are getting passed in a network. It can figure it out. Then digital advertising and customer targeting. This is one of the major ways to make money in this space. So Google has like made more than 2 billions in revenue because of the algorithms developed by DeepMind, which are again mostly used or using these deep learning techniques itself. So they know better to target you. So based on your pictures, your shopping trends, or your regularly what you're searching on Amazon, you might have seen a lot of websites these days. So these have ads in their sidebars, and whenever you search something on Amazon, they like pop right there. Okay. So whatever you are searching, it is kind of giving them a history or like a recommendation that this is what they want. And deep learning or like neural networks are very good at finding these patterns and kind of predicting when you will buy this stuff or how much price will be the best price where you will buy this stuff. Let's talk about the course. So that was a basic about intro about like what deep learning is and what we intend to do. So this course is of total hours of 75 hours. And it's kind of an instructor-based course, so I will be your instructor and course can be done in class as well as online as well. It's a pretty much hands-on course with focus on implementation. So you will need to bring your laptops and I will help you in installing the environments and everything so that you can even implement the code as soon as possible. It's a weekend class, so every weekend, Saturday, Sunday, should take almost 10 to 12 weeks to finish. Your access to recorded videos will be there even when you're finished with this course and can come back even to revise the concept later as well. With let's say if you are forgetting some concept, you can come back. If let's say a second batch is going on, you can just sit there and just listen and get your concepts cleared once again. You will be working on real world projects, very real time projects as uh, Learnbay will help you in resume preparation, interview guidance, and placement assistant, as well as we will be provided with a certification on completion. Uh, Before I go any forward, let me just go through the complete thing anyways. Before going deep into that, these are like course prerequisites. So you should be very familiar with programming in Python or R. You should have good mathematical intuition. Again, I'm just asking for basics, nothing very serious. Linear algebra, calculus, probability. Your basics should, if you already have some basics in data science or machine learning, that would be supremely helpful while learning deep learning. This other part is about more on the commercial side, that if you understand business requirements very well, you will be able to figure it out where to use DL exactly. You should be comfortable with using a lot of open source libraries because most of this work in DL and their frameworks are still very much open source, and every day a new library comes and sometimes it might be useful. So you should be very comfortable. Have an aptitude to learn new ideas, and that's very important in this class. Please share your learning and collaborate with other people if needed. Be curious. Last but not the least, have fun while learning. And let me go through the complete course template just once for you guys. Okay. I hope I have that with me. Okay, and thank you. And please contact us at contact@learnbay.in and just give me 1 second. I will get the course for you. I hope you can see this. Yeah. So this is kind of the brochure right now, which we have prepared. And this is artificial intelligence training. So this complete course is about artificial intelligence, just not machine learning. And the course features are online and classroom artificial intelligence training by industry experts. These would be 40% theory, 60% hands-on. As I have already told you, you will have to work on projects as well as even some live code within the class itself. Most of our the trainers have 10 plus years of experience and they are working in multiple domains as well. And we kind of take this practical approach with many project and case studies. And who should attend really? So any person who wants to become or wants to artificial intelligence and its underlying areas such as machine learning, deep learning, NLP or CV, business analysts, data analysts who wants to improve their skills, freshers and experienced professional managers, IT professionals, this course is relevant to them all. The course and kind of overview is with machine learning and deep learning and NLP, natural language processing in depth, then deep learning with Tensor Flow, project and resume prep session, interview guidance and job assistance. Again, you should be kind of familiar with Python programming and machine learning to be eligible for AI course. Otherwise, it becomes very hard if we have to teach you Python. But we do teach Python. So if you want to learn Python first, do contact us. And this is the duration of course, 75 hours. The overall weeks might increase 10 to 12, that's the range. And the course fee is rupees 55,000 and that would be with taxes. And that is GST. So course content is a very basic introduction to artificial intelligence. Some of the stuff that I talked today itself would be there. That would be what is artificial intelligence, importance of this field, types of intelligence, applications, difference between human and machine intelligence, tools and technologies, and demand for AI and ML professionals. Then one part is natural language processing, where you kind of go with this NLP and text analytics, which deals with all these basics, NLP libraries, text analytics, words frequency algorithms, semantic analysis. You have text pre-processing and various methods to process the text data, stemming, and all the table lookup approach, n-gram stemmers. Distance algorithms used in text analytics, string similarity, cosine similarity, and LCS, problem solution, LCS algorithms, information retrieval systems, where you deal with precision recall, F-score, TF-IDF, KNN, and K-means as well. Topic modeling and Dirichlet distribution, and then you have projects and case studies. This is the main part, deep learning with TensorFlow and Keras. So again, introduction, where we kind of deal with machine learning versus deep learning, limitations, what we can solve through deep learning, advantages. Some of them I have already talked today. Then we will start with like basic TensorFlow. We'll kind of install TensorFlow, teach you basics of graph, how to build a model, and then how you do a classification. So the TensorFlow playground example which we saw, we will try to implement through the TensorFlow just through your own computers. Then we kind of try to understand the basic neural networks, single hidden layer, multiple hidden layer, backpropagation, how the backpropagation even works. And then you go to tensor convolution neural networks and how the architecture works, how pooling works, what is a deep CNN, and how to understand and visualize the CNN. Again, TensorBoard will be very useful in that. Then we go to a next one, that is RNN. This is mostly used in LSTM and with GRU. And obviously we will also talk about RBMs and autoencoders. Then we will go with TF-Learn APIs. So you will also understand how to use these APIs while building a model. So you can just kind of take these APIs and integrate them within your apps. Keras is just a layer on top of the TensorFlow idea that we have this, and we kind of put Keras for faster execution or faster prototyping. Again, you have project and case studies. You will be building a CNN for image classification as well as a spam prediction using the RNN. And then we have computer vision, which kind of first introduces the basic computer vision, gives the historical perspective. Then we see the data-driven approach where we go with k nearest neighbor and linear classifications. We have these OpenCV libraries, and again, mostly it would be basically a Python OpenCV itself. And you will see how you kind of draw shapes and image rotation. And some basic pre-processing, this could be Gaussian blur, median blur, how to detect them and how to remove them. Then how do we use neural networks in CV, that is multiplayer perceptron and backpropagation. This would be pretty much a revision which you already have done. And then you will go with this convolution neural networks, and you will mostly be dealing with activation function, initialization, dropout, update rules. And then there is a very good tool, kind of a like good algorithm, like that is called single shot detection, that is for object detection. And you will figure it out how to kind of figure out what object is where in that image, draw a bounding box and kind of predict what is it. So, and we will be implementing that in SSD in TensorFlow. And then we have a small unit for face detection. And again, we will have project using computer vision and deep learning. I have already talked about these things. Let's move ahead. So again, very basic FAQs, which so most of the trainers are highly experienced and have experience with the commercial or the research. And they are working in MNCs as either ML or deep learning engineers or even as a data scientist. Do carry your laptop, and we will be actually going with Python for most of the TensorFlow work anyways. So I will help you installing TensorFlow and all the Python dependencies. Yes, sir, you can actually attend a live demo session before enrolling for the course so that you are supremely confident that this is the right course for you. Yes, it is completely online as well as in classroom session. Both are up to you. If someday you are not feeling well or you cannot come there, you can just watch the recordings online as well and do all the homework and whatever the assignments have been given to you. Yes, you are always given the class recordings, and they will always be shared with you. For any more questions, do contact Learnbay at contact@learnbay.in. And it's been a pleasure talking to you guys, and hope you guys are registered for this course and we continue our journey in exploration of DL. Thank you. Thanks a lot.
Yeah, thanks, Amrita.
Yeah.